So in yesterday's demo sessions, we have learned about what exactly the data and the three terminologies in the data domain, that is data engineer, scientist, and also the data analyst. So we got to know the difference between all these three domains and the different terminologies what we use, right? So all these things we learned yesterday's demo session. So today let's dive like how to use the ETL tool, right? ETL tool with the help of Excel, and also we'll learn some of the statistical analysis that is called as descriptive analysis with the help of Excel. Okay, so we'll learn all those things. So now when it comes to the latest version, what we are using in the Excel is Microsoft 365. And mainly this is the latest version, and it is a paid version which gives us a lot of advanced formulas in the functions to use it, right? So here we have the data tab. So that is, we have a file. So in file, we can do all the basic activities like we can create a new file, we can share the particular document to the team members, save as, export, close, all the same. And account settings can be made it over here. And similar way, so we have here insert, page layout, and also the formula bar, data tab. And again, we have review, view, developer, and help data streamer. It is customized one. And we have Power Pivot and SAP Analytics Cloud. So if we have the cloud integrated with the Excel, so these all options will be available. So it should be having a business account. So to sign into that, okay. So this is the one. And here, most important part here is the home insert part. You'll be navigating and the page in the previous experience whenever you were using the Excel. I think the conditional formatting and the table format, cell styles. So these are all the very old one. So what is the advanced one here we have to learn is one is VBA, that is basic programming language of the Excel. Along with the formulas we have to upgrade on, and the page layouts, the data tab. So here it comes very important part. For an example, suppose you want to know the descriptive statistic, what exactly my previous data here. I'll just add some of the sales details. So let me add product. Okay. So, and here I'll add with the sales. Okay. So now I have two columns. One is with the product and the sales. And let me add product A, product B, product C, product D, E, F, G. Okay. So now sales I'll add in the units, 100 units, 200, 20, 20, 34, 190, 250. So this is the quantity of the sales of the particular products. So it is a random data what I'm taking here. So to put the border for entire column, so what we have to do, so just select the data, Alt HBA, right? Alt HBA is a shortcut key where we can use this sales like the two columns for the bordering. And now the alignment also you can make it accordingly, right? So, and also you can fill the color. So this is the one, the basic data preparations, data entry what I'm doing. So now the task is we have to perform the descriptive statistics in the Excel. Why descriptive statistics is very important, and what is descriptive statistics? So basically descriptive statistics are nothing but it is a calculations of statistical methods, that is of it, the central tendency, the calculation of central tendency. What is central tendency? Here, in the central tendency, we can calculate mean, mode, median. Along with that, the structure of the data like standard deviation, variance, the largest number, highest number, sum, count at a time. So if you want to calculate the sum of this sales, So what the quantity of sales, what you have to do, so you can press Alt equal to. Alt equal to. So see, so it shows that sum of from B2 to B8. So just click enter, so you'll be having 814. So or else you would have written manually with the sum formula, and you'll be selecting the set of range, data range, what has to be summed up, and you'll be closing the parenthesis and the same results you'll be having. So to calculate the sum of the column, what we'll be using, we are using here Alt equal to is a shortcut key. Okay, so this is the one. So I don't want to write, if in case I want to calculate with the mean value. Mean is what? Mean is the average of the sales. So for that I need to add the average formula. So to avoid that, we have in the data tab, that is data analysis. So what is this data analysis? It is a tool where I can perform the financial and statistical data analysis can be done. If in case you are using the older version or else you are using the 2021 version of the Excel, still you are able to enable this one with the help of ribbon. So for an example, so here just right click on the ribbon anywhere in the blank space in the ribbon, you can right click. So or else here anywhere you can right click and just open the customize the ribbon. Okay, if you open the customize the ribbon, so here we'll be having all the setting option. Just if you want to enable the data analysis toolpack, then in the customize ribbon, you can click on add-ins. So here below to the customize ribbon, there is an add-in. So here the first one, analysis toolpack, you have to select. And then coming down, so here manage. By default, it will be Excel add-ins. So you have to select the Excel add-ins only and click on go. Okay, once you click on go, so here if in case this particular tab is not available in your desktop, so then what does it shows? It shows with a blank add-ins available. So you have to enable it by tick mark and click on OK. So once you do that, so this particular data analysis will be performed for you. Hello? Sorry for that. So here we have to enable this. So one method is with the right clicking the ribbon, customize the ribbon, add an analysis toolpack, and we'll be enabling the by default one, that is Excel add-ins, and we'll enable that with a tick mark and click on go. So this is one method of enabling the data analysis toolpack. And similarly, so if you go to the file, okay, click on the file, and here we have an options. Click on the options. So again, add-ins, the same process, analysis toolpack, Excel add-in, go, and here you have to enable and click OK. So these are the two ways where you can enable the data analysis toolpack in your Excel. Okay. So once you are enabled, just open that. So now you can select with the descriptive statistics and click OK. So these are the various, we have ANOVA, correlation, variance, and exponential smoothing, F-test, right? So, and also we have here Fortier, moving averages, random number generation, rank and percentile regressions, sampling, t-test, z-test, right? So what are these things? These are the terminologies we use in the statistics. This is a statistical and mathematical tool, the combination which is helpful for the data analysis. So now we are doing the statistical tools, that is a descriptive statistics. What does this descriptive means? Descriptive is nothing but we will be describing our data, how it is divided into the wider version. So here select descriptive statistics, click OK. So once you give OK, so here the descriptive statistics dialog box is open. So we have to add the input range. So what is this input range? Input range, we have to add here the data range. So here I'll select this one because I have a values in this column. I'll select from B1 to B8, and this particular rows, the columns has been locked. And here first label, first row. So label in the first row, yes. So I have heading in the first row that is of B1. So I'll just enable that. And again, output range it asks for, let me show you here only in the D1. So just up arrow and select the cell and again down arrow. And here you have to enable the statistical summary, or else if you want to get the output from different sheet, you can select the different sheet, or else different workbook. If you want to create with a new workbook, you can select that. So as of now, I'll show you with the output range in the same sheet to know the differences, and we can compare both the data. And again here, if you want the confidence level of the mean and also the kth largest and kth smallest, so these both option data I'll be getting from the statistic summary only. So we'll see how does our data looks like. So here input range, I'll be adding the value of the data what I need to be calculated with the descriptive statistics and group by the column. So we are dealing with the columns, and my first row has a header, so that's why I'll be label in the first row. And the output range, I'm using the D1, and here the statistic summary and also the all the available options in the descriptive statistics I have enabled, and I'll just give OK. So now here you can see there is a calculations of all the sales. Sales is what? Sales is a column name. So for that, we have calculated the descriptive statistics. So here we have calculated all these things. So here you can see the first one, mean. Mean is what? Mean is nothing but it is the average of the sales. Okay. So here we have 1, 2, 3, 4, 5, 6, 7. 7 data set we have. So along with that, if I add all these things, suppose the total of all the value of the sales is 814. So here we have the sum. And if 814 is divided by 7, then the count of the numbers. So if it is divided by 7, so then we'll be getting 116.28. So what is this? This is a mean value. It is also called as an average. Okay. So if they ask you in the interview, like how do you calculate the descriptive statistics in Excel? So you can answer the process what we done. So first we have to enable the data analysis toolpack. Once it is done, we have to, select the data range, input range, and also the output range and summary statistics. So we'll be having all the details. So what all it includes? It includes mean, median, mode. Okay, standard error, standard deviation, sampling variance, kurtosis, skewness, range. So here median is nothing but if the data set is arranged in an ascending order, the middle value will be considered as a median value. And what is mode now? So mode is nothing but mode is a repetitive value. So here you can see, so 20, 20, it is repeated twice, right? So most repeated values are called as mode. And median is if this particular sales data is arranged in an ascending order, the middle value, right? So the middle output. So see, you can see here, I have arranged this sales data in an ascending order. After assigning the data, so you can see the middle value. So here total we have 7 counts. If it divided by 3 and 3, so what will be our middle number? So middle is of median. So I have 100 as a median value. Okay, and the mode is what? Mode is a most repeated value. So here 20 is repeated twice. So mode is a repeated value. And the standard deviation, which is connected with the mean. So where I'll be getting the relationship between mean by the help of standard deviation. And also the variance, we have variance are nothing but it's a square root of standard deviation is of variance. And similarly, we have a kurtosis and skewness. And range. So what is this range? Range is nothing but it is a difference between the median, sorry, maximum and the minimum value is called as a range. It is a difference between if 250 is divided, sorry, it is subtracted with the 20. So then we'll be getting 230, which means the difference between largest and the minimum value is known as range. And we have a sum is what? Sum is a total count of the values, and here the number of count is 7, and again the largest value and the smallest value. See, this is the kth largest and kth smallest, so minimum and maximum value are also the same output. So this is how we can calculate, and the confidential level of the mean is 89.28. Sorry, 26. So these are the descriptive statistics what we can make to analyze and read the data. Okay, so here if you go and do the descriptive statistics for every column, you'll be understanding so how the data is flowing and what are the missing values we have and all those things details in the descriptive summary. So we'll be getting. So as of now, we don't have any missing values out there. So the data looks perfect. And here one more thing we have to learn. So this is a data analytics. So in the live classes, we can learn all these things individually like ANOVA, correlation, coefficient. So why those are used in the sense to see the variable. Suppose this is one of the variable. Okay, product is one of the variable which holds the product details. And we have a sales. Sales is another variable. We have a sales details in it, right? So that's why. So analyzing the variables, so two variables is known as descriptive analyzing the two variables and finding the difference between the two variables are known as correlation. And even ANOVA also deal with the two variables only, right? So analyzing the difference between whether we have a positive correlation or negative correlation, which will be helping. Why we need to calculate all these things in the sense it helps us to find the decisions, right? To make a proper decision with the scalar in the smaller line, thin line structure, we'll be using this statistical analysis. So this is the one, this data analytics. In that analytics, we are done with only one part, that is of descriptive statistics, how to calculate and what are the things we'll be having inside that descriptive statistics and what are the meaning of the terminologies, right? Any doubts in this so far?
Yeah, I don't understand the kurtosis, the skewness. I'm not sure I understood that very well. And then maybe the confidence level, please.
Yes. So here, what is kurtosis and what is skewness, right? So what is kurtosis and the skewness? So here, these both are, the statistical terminologies. Kurtosis and like we can tell it as, one second, I'll just show you with the diagram. Yeah. So here we have a kurtosis and the skewness images. See? So here first one, the kurtosis. The kurtosis is nothing but it is a measurement of headed and the peak point. So if the value, if I compare with the two variable and I got the value in between, like I do the graphing for the values of the variable what I have. Suppose 1, 2, 3, 4, 5 and minus values, it will be there. So what I'll do, I'll plot the graph and I'll just connect with the graph. Okay. So if the graph is looking like this in the peak away, like a mountain shape. So what does it says? It is a positive kurtosis. The shape of the diagram, if the value, if I plot in the graph, if that is in the peak away, so if it creates a peak at the top header, so it is called as a positive distribution. On what value we will be doing? On the basis of probability distribution. Probability distribution is one of the wider concept in the statistics. So where this kurtosis and the probability distribution, it will be a positive one. So the positive says that, so this is in the higher distribution, so it is called as a normal distribution. Okay, so similarly, so if it is in the this one, this is a normal and this is negative. So high peak is called as positive, and the like little curvy wave of the graph, the lines, is known as a normal distribution. And also the low kurtosis, we can say that is of, you know, negative distribution. So it depends on the probability distribution of the two variables basically. So how it is, how vast it is divided. So by this you can make a decision whether my kurtosis, the value of the variable, is positive or negative or neutral. It is helps us to decision making. Okay, so when it comes to this one, so we
No,
can say
sorry.
here,
Before you
this
leave the currencies, when it's positive, what does it mean? And when it's negative, what does it mean? And when it's normal, what does it mean?
Yeah. I'm explaining you that only here. So here the kurtosis is nothing but we got the minus value by this variable. So we can say that it is a negative kurtosis. So in the graph, if you plot, like it is a basic example, we have to take with the 2 or 3 variables in a consideration. For an example, so we are understanding the concept of kurtosis, right? So here the kurtosis, it is a, just understand, it is a calculation of probability distribution. Kurtosis is a terminology. We can plot the graphs according to the calculations what we make on variables. Okay, so the first point. And it is automatically calculated with the kurtosis. There is a different formulas and figures. We can do it manually. But as of now, we have an inbuilt function in the data analysis, which performs in the backend with the formulas of kurtosis for this particular data set. And here we will be adding like after the calculation of the variable. So here we are considering only one column, that is of sales column, which is from 20 to 250. We got like minus 2 as a value, right? So this minus 2 which says that it is a negative. So if you plot the same graph, so it looks like this one, the blue line you say here, the negative
Yeah.
the negative one will be showing out here. So if you join, so here I have taken only one variable. If you try out with the multiple variables, and if you try plotting joining of all the lines, all the values in the graph, so you'll be getting the shape like this, the negative one, right? So it says that negative kurtosis. You got the output, you can say that. So the difference of the variable, the kurtosis, so I have a value of negative. And when it comes to the skewness, so these are the positively skewed and negatively skewed. So if you join a block of values in the graph, okay, you are plotting. So this is the x-axis. And suppose for an example, let me open a notepad. So let us take, this is a graph you are drawing. Okay. So this is a point, and this is y-axis, and this is x-axis. Okay. So here, if you are joining, so some of the values, so it will be like this. Okay. If the value you are joining, and it will be like something like this. Okay, so if it is like this, it is exactly, we can divide it into a two. It is called as a normal distribution. If it is the values you are plotting, if it is in the higher peak, right? So it is called as a positive skewed, positive kurtosis. And here if it is the low value it is there, so then we can call it as,
Negative.
negative, right? This is the one concept we learned. And
Mhm.
similarly, so here, the next concept is what? So this one, you can compare with the diagram.
Mm-hmm.
And here the skewness. Skewness is what? Skewness is a measure of asymmetry of the probability distribution, which derives the distribution whether it is a positive or negative. In the sense, we are getting more clarification of the variable, whether it is a positive or negative. So how we can do that? If the distribution has a longer tail like this. Okay, so let me draw. If suppose this is the distributions we can take, okay, for this skewness. If the value has a longer tail at the pointer, so from here only, so if we have a longer tail and the drop down in the variable value like this, so here it is what? It is a peak level, and coming down it is reducing. Okay, so whatever the value we here will be getting during the reduction, these values are called as outliers. What it is? Outlier. Okay, so this is the outlier, and this we can tell it as positive. So here, what is the definition of positive skewed? So if I plot the value of the variables, whatever we have calculated, so if we plot on a graph and the distributions are nothing but it is a probability distribution, the chances of the value. So from the right side, okay, so we'll be getting in the right side the tail. So if it is a graph, so this is the left side and this is the right side, right? So left side will be the higher value and the left side it will be decreasing right side, right? So this is the way of presenting the graph. It is called as, if the values are distributed in this way, so we'll be calling it as a positively skewed. So the simple, in the left side there will be a huge value and in the right side it will be a lower value. So this is the one. So we can call it as a positively skewed. And negative skewed is opposite to that. So we'll be having, see, so here, if it is distributed in this way, so we can divide that, and like this, it will be distributed to the peaker point. So basically, how do we draw this? This is called as negative. Opposite to the positive skewness, it is a negative one. So the same thing, the meaning of the negative skewed is also the distribution has a longer tail on the left side, indicating the extreme values and also which occurs on the left side. So similarly, in the right side, there will be an outlier wherever we have a low data. So like this, if it is a low values available, so that is called as a outliers. So basically the both, why we need to use this one. So the main intention of using of skewness and kurtosis are outliers. So what is this outliers in the sense? Outliers are the unknown values, right? Unknown values which is connected with our variable, but it is out of range. Okay, so we don't have the information or a data or something, one or the other problem with the missing data will be there, which is not at all related to the analysis what we are doing. That kind of data are known as outliers, so which damages to our data. So for an example, let us take some of the motor vehicle company wants to establish their entity and they have to expand their franchisees. Okay, so this is the scenario. So now they have to do the analysis in what location I can make it out. Whether I have to do it in a Hyderabad or I have to go with the Mumbai locations. So they are in the confusions of it. Okay. Suppose in the Hyderabad and the Mumbai, the lifestyle of the people are same. So everyone are in the, we can tell it as a neutral. So where there is a high standard peoples are also living and the low standard peoples are also living. So we can go for the both the location for establishment of the motor vehicle. Let us take a car manufacturing company. So this car manufacturing company analyzes. Suppose I need to go for Hyderabad or Mumbai. Imagine that they select with the Hyderabad. On what basis they'll select? Suppose in Hyderabad, so they'll be checking with the income statement of the people, right? So how the income is generated for the people. So they'll collect all the information, the financial information of the demography, and then they will allocate that which city is good to establish. Okay. So now what happens? The question is, so we have to identify in very deeper way which location. Okay. So if in case in the Mumbai, so there is average income. Just imagine there is an average level compared to Hyderabad. Okay. Why? Because in Hyderabad, suppose high rich peoples are living in the Hyderabad and their income levels are high. And if you do the statistics of that income, you'll be, of course, getting the higher range. But when it comes to the Mumbai, so if in case any one of the person or two of the person who are getting higher salary and rest of them are in the average range, and but the value will be increased over here in the Mumbai also. So at that time, what we can make, so it creates an outlier that only because of the two persons, entire data is getting affected. So
Right.
that's why this is called as a outlier and we have to remove that. So I'll tell you the techniques how we can remove this outliers. So we will be finding outliers with the help of skewness and kurtosis. Along with that, we have a box plot. So if we use the box plot, it is one of the diagram. So, and it is also a statistical tool. So if we do that, we'll be understanding the data which is not relevant to our analysis, right? So this is one of the thing we can do, and it will be helping us to detect all the outliers and find the cleaned data from it, right? So this is the one. And yeah, this is the skewness and kurtosis differences, but this is completely into statistics. And yeah, it comes under the probability distributions.
Okay. And then these outliers, are they like null values or something?
Sorry?
Are they null values? Can you also classify them as null values? Or they will have figures, but they are just not in range with, maybe let's say you have ranges of between 20 to 30, and then next thing you have like 100 and 120. That's not like out of range. Or is it a null value? Is what I'm trying to find out. The outlier.
In the data set, right?
Yes, yes.
Okay, 1 second. Let me erase this one. Yeah, here for an example, so this is just the sales data I have taken for all the products. So for an example here, what happens? So let us take a cities like Bangalore, okay, Bangalore, and also we'll take some any other. Let me take Hyderabad. Okay, so here let us take the income. So income of that Bangalore, suppose we are getting on an average of 15, okay, 15%. And here we are getting 25%. Okay, so but on what basis we are calculating? Just it is a demographic. I'm just showing with a random data, so it's not accurate one. So here what happens? So the people demography. So we have to get all the income statements and all the average income of the employees or people. So where do we get from the organizations, and also the demography, whatever we get in the public repositories of the government sector. So there we will be getting the behavior of the human based on the location. So this is the one we can extract with the data with the help of web scraping and all. So we can get these data. Okay. So after getting, so we'll be analyzing the behavior of the employee, how the salary rate is going on. Suppose imagine this Bangalore people are having a good income. Okay. And but it is an average. Okay. So average, we can take it as average compared to Hyderabad. Suppose any one of the additions to this in Bangalore, suppose any president or any of the businessman like Ambani comes to the Bangalore and stays uh, for a couple of years. Okay, so here Ambani's income is very high, and what happens? The average of the income of the Bangalore will drastically changes to the 35. Okay, only because of one person entering to the city, that is Bangalore. So now how we can predict that this 35, he may go to his place anytime. Okay, so if by considering the Ambani's arrival or any one of the outlier, we can't predict that this Bangalore is a best place to open the motor vehicle. Okay, so it is not the way to predict. So that's why we have to plot a graph. So if we plot a graph, we'll be knowing that it is a positive or negative, and where there is an outlier. So outlier is the value which creates a drastic, in the sense there is a huge move. So if you are creating an average for this, so you'll be having the accurate value that the average is of 116. Right, so if you create an average over here, so it gives you the different number, but still if you are plotting with a graph for individual persons, then again it shows you the outliers. Okay, I don't have a data set over here, so if possible I'll show it tomorrow. Okay, so this is how, just understand the concept outlier, how does it exist. So here in the Bangalore we have, so again right, Bangalore we have, so this is the one of the city, and here again we have 15 was our earlier average of the salary. Okay, 15 percentage in the Bangalore location. Any one of the person enters to the Bangalore which having the higher salary rate, right? So it only with the one person I'm getting hike of 10 percentage in the salary. Okay, 10 or 20%. So what does it happens? So it creates an outlier here. So it will be of 35%. Because of one person, because of one person, if I establish my car showroom over here in Bangalore, it may affect me in the future. The decision, the crucial part of taking the decision, by the only by considering, okay, one person is giving us a contribution of 20% in the income for this Bangalore currently at present. So what happens in the future if he go back to his place living the Bangalore, again his income will be lost. So this 20% will be again gone, right? So again, it will be left with the 15%. So at this point, decision making is very crucial. So for that only we'll be using the probability distribution. If the distribution is normal or it is in the peak, as of now it shows it with the peaker only, as if we have it, but we have to concentrate on the outliers, how much it is presented, where outlier will be presented at the bottom here. So if it is the distribution and we are drawing here, so here it will be the dots, so somewhere here, so we will be connecting like this, right? So all these values shows that it is an outlier. Okay, so we will discuss all these things with a real-time example, but the thing is, you have to understand the concept. What is outlier? Outliers are the data which affects the original data. Okay, and here, how does it affects? By, how we can detect that with the help of box plot. Okay, with the help of box plot, we can detect the outlier, and also with the help of skewness and kurtosis and skewness, whether it is a positive or negative, we can fetch it out the details. Uh, and yeah, these are the ways we can calculate the outliers. So box plot is one of the good example to calculate the outlier. And also this is the alternative way to calculate it. So it's just we are getting whether it is a positive or negative. Kurtosis we have a negative, and the skewness we have a positive. In the sense there is a higher peaker like this. The graph is divided like this. So it says that it is a positive, right? And the negative, so we have the negative on the basis of what? On the basis of what? We don't know, because we have only the one variable. It is a auto-generated. So if we concentrate mainly into the kurtosis and mainly into the skewness, so it would have take some of the formulas wider one. So we can calculate that as well.
Okay. Thank you.
Thank you. So what is this confidence level of the mean in the descriptive statistics? This is the one question you have asked, right? So for this also, so the confidence level of the mean is nothing but, so it gives us the average of the level here, the mean, whatever we have calculated. Again, it will present the confidential level of the mean value. So here, if you extend, so there is something, 1 second. So even this is one of the the range, the calculation of the range of the confidential level of the mean. So here we have a three types. One is 95%, 99%, and also the 90%. Three levels of confidence we can calculate. So here the mean value, if the mean value we have with 116, and here if it is calculated with the 95%, and the standard deviation will be the 5. Okay, so the standard deviation here we have a 96 only. So this 96 along with the error, it will be considering for the calculation, and also the number of items. So how many number of items we have? We have the 7 number of items. These all 3 units it will be considering for the calculations of the confidential level. So basically the probability of the sales mean lies between somewhere around here 89 to 89.2 to 83. We can take a round figure. So where does this confidential level stands? In the sense you can write it lies between 89.2 or else 89.2 to 90. So we can take a like one number exceed. So in between this, the level of the confidence will lies. And somewhere, so here the three common types we have. So the basic formula of this calculation manual is, so we'll be considering here, let me clear. So here the calculation of the standard, the confidential level is, we will be taking mean value. Okay, so the symbol is called mean value, and along with that we have to take the z-score. So z-score we haven't calculated over here, but it will be calculated manually as of now. But the formula it takes with the z-score, that is z-test, we can do it. and then it will be multiplied. Okay, it will be multiplied with standard deviation. Okay, the standard deviation, and also the root of n. Root of n is nothing but a root of 7, the number of value what we have. So if you add all the values to this formula and if you calculate, you'll be having the values of 89.2. So this is the formula to calculate the confidential level. So there is a 3 kinds of confidential level. One is 95, 95, 90, and 99. 90 and 99. Right? So what is this? These are the 3 kinds of confidential level we have. So basically what is that? So it is a mean. Okay. Mean of the probability distribution, which gives what is a true value, exact value. It is a 95 or 90 or 99 confidence level. I can take it out. So you can take 95 level of confidential once you apply with this formula. But it is a little tricky, but this is a thing. But in the data analysis, we won't use this one, but for the understanding purpose of this terminology and this too, so we have to understand it. So apart from these two, so this is completely purely statistics. Okay, it doesn't include in the data analytics domain exactly these two. Rest of the things we have to focus on. So mean, median, mode, standard error, and also standard deviation, variance. And here we have the range, minimum, maximum value, sum of count, and largest, and this thing. You have to focus on this one. So majority, so this doesn't comes in the roles and responsibility of the data analytics. For the knowledge purpose, for to gain the skills on it, how to calculate, we can learn this. And this is the formula for calculation of the standard.
Who are not the ones that use it? If it's not data analyst, who uses all this QNS and all? Who uses it?
Yeah, data scientist he'll be using. He'll be
Oh,
using along with that. So z-test, t-test, and we have chi-square, right? So this one, so which will be helping them to see the minor changes in the data and how it is varying. Like the thin layer of the data calculations can be done with the statistics. So that's how the data scientists, they'll be working on with the statistics, machine learning to identify the patterns in the data.
okay.
Yeah.
But we're sure we don't need to bother ourselves on it because it looks a bit complicated.
Yeah, it's very complicated actually.
I was trying to understand, but I was a bit confused. But anyways, it's fine.
Yeah, like slowly it will be grabbing. So as of now, we are reading for the first time, right? It will be confusing. So if you keep on practicing with that, the same terminologies and the same data set, so you'll be used to it. So then it will be easy for you.
Okay, thank you.
Yep, thank you, Elspeth. So do we have any doubts? Amulya, Anushri, Janvi, Manideep, Preeti, Sai Soumya, and Soumya Dev. So far don't have any. Okay, thank you, thank you. So and Soumya Dev, hi Soumya Dev. So is this your first class?
Yes.
Okay, can I have your quick introduction, please?
Okay. I completed BTech in 2016.
Okay.
I worked for 5 years.
Mm-hmm.
Uh, and from 2 years onwards, I'm not doing any job. Now I want to learn the data analytics.
Okay, perfect. Soumya, like 5 years of experience into what domain you have?
Data stage.
Okay, perfect, Soumya. And Anushri?
Hello,
So,
good morning.
yes,
Am I
Anushri, you are-
audible?
yes.
Okay. I did my master's in electronics and telecommunication only, and after that, for 2.5 years, I did job, and now looking for a domain change. I worked into automotive industry.
Okay, Anushri, no worries. You can easily add your experience into data analytics and you can switch to the different domain.
Yeah.
So, and yes, so any doubts?
No, Eshwari.
Okay, thank you all. Thank you, Anushri, Amulya,
Thank you.
Elizabeth, Sanvi, Manideep, Preeti, Sai, Soumya, and also Soumya Dev. So we'll connect tomorrow, right? Thank you.
Thank you so much.
Thank you.
Thank you.
Thank
Bye.
you.